Hey there. So this is the third week of online learning stuff, and we're going to continue with our vector stuff. So you've done stuff where you've found component form from the points and found the magnitude and stuff, and now we're going to kind of break it down going the other way. So they're going to give us the uh, magnitude and the direction angle of the vector, and we got to figure out what are the component forms. So just kind of for a quick reminder, we're looking for the component form on my way that I found to screencast and do the video myself. So component form, right? We're looking for brackets like this. Sorry about the handwriting. And then it's our x component and our y component. So it says like how far we went right and left, how far we went up and down. So with this saying, we have a vector, and the vector has a magnitude of 10. So right, that's how we do a vector. It's a half arrow. So our magnitude is 10 and our angle is 48 degrees. So just saying this angle here is 48 degrees, just kind of like we would do with basic trigonometry. Okay, that's a degree sign. So what we're going to do to find our component form, to find component form when we're given this, it is, so our x, right? So our x is going to be figured out with trig. We're just going to make this into kind of a triangle, right? So this is our x. So our x comes from adjacent over hypotenuse, so it is the cosine. Okay, so it is what we do is we take the magnitude 10. So what they do, they make that the absolute value v, that would be magnitude. Okay, and then the cosine of the angle. Okay, and then our y value, just like the same thing, is the absolute value of v, or the magnitude, and that will be the sine of the angle. Okay, so in this case, we would do, so to find our component form, it would be 10 cosine of 48 and 10 sine of 48. Okay, so that would give us our x and our y component, which would tell us how far we go from here to here with our x component and our y component. Okay, so then if I just plug that into my calculator here, which I happen to have up, so it would be 10 cosine of 48. Make sure you are in the right thing, degrees or radians. If they give you radians instead, it's the exact same thing. Okay, so it's still the same formulas. So our x is 6.69, so I'm just going to round that to 6.69. And so we're going to have 6.69? 6.69 for our x, and then use the sine to find our y. 10 sine of 48. That, and it is 7.43. 7.43. Okay, so that says that to get from this point to the end of the vector, it's 6.69 to the right and 7.43 up. Okay, so that's how you find the component form of a vector. Okay. Next one, we're going to find our direction angle of a vector. Okay, once again, it's pretty much just basic trig. So here it's 2, -3. So we can also do them on a coordinate plane. If you ever see them on a coordinate plane, they're just put on the origin. Sorry about that. I'll put my pen back up here if I can. Oh, so if you see 2, -3, or they're on a coordinate plane, that just means my vector goes 2 to the right and 3 down. So it'd be like somewhere down here. So this is our vector. It's always centered with the origin. Okay, and then once again, we just have to make our triangle to figure out our angle here. We can find our magnitude too. Magnitude is just straight Pythagorean theorem. But when we find our angle, we're going to find this angle. Okay, or actually the other way around would be fine too. There's multiple ways to do it. But so if you remember, to find this angle, we know that this here is 2. This is -3. It's weird looking 3. Okay, but I have an opposite and adjacent, so we will use tangent. So to find our direction angle, we're going to say tangent of an angle equals opposite over adjacent, so it is TOA, -3/2, right? So it would be inverse tangent of -3/2 will give me my angle. All right, so let's see if I can do that on my calculator here. So there, again, maybe not. Sorry about that. I had to get a new calculator. But so inverse tangent of -3/2. If I go here, then I can go. Then we get -56.3 degrees. I'm just going to round it to straight -56 degrees. So that says is that this angle is -56 degrees. It goes down. So right there, -56 degrees, which would be fine. You could say that. It's kind of weird to say it as a negative. You could also say that this angle, the angle of the vector, if I started on this spot, would be all the way around, right? So we could say that it is 304 degrees because 360 degrees in a full circle. Okay, so that's how we can find our direction angle. Last one here. Okay, so we have find the horizontal and vertical components of an arrow shot at 70 miles per hour at an angle of elevation of 12 degrees. So it's not saying what is the distance traveled like we did in the past. What it's saying is when he shoots the arrow or she shoots the arrow, what is the actual speed that it's going horizontally and what is the speed that it's going vertically. So gravity is not something we were about here. So really we're just going to draw ourselves a vector. So like you got some dude here or non gotta get my pen. Some person here shooting an arrow. It's really hard to draw on my Chromebook. So that's the person. They shot an arrow. Okay. And what we're saying is this arrow is this is our vector. Okay, so I'm just going to make the vector over here. So we have this vector. This is 12 degrees, right? It's going 70 miles per hour. So we want to know our component form. It's just like we did in the first problem, right? Just make a triangle. It doesn't matter how long the triangle is because we're not talking about like what's the distance traveled. We're talking strictly what is the speed going in a vertical way and in a horizontal way when it leaves the bow. So all we'd have to do is figure out this part and this part, right? So we have this, so it would be the exact same thing. So our horizontal, our x, right, is going to be 70 times cosine of 12. Okay, and I can plug that in. 70 cosine of 12, I'm in degrees. So it's going 68.47 miles an hour in a horizontal way. So 60. So our x would be 68.47. Okay, and then to find our y, it's going to be 70 sine of 12. Sorry about the handwriting again, but plug that in. We'll get 70 sine of 12, which would be 14.5. Okay, miles per hour. Same here. Can't fit my finger in there, but that's miles per hour over here. Okay, so that just tells me that, like, so when they shoot the arrow, it would be going 68.47 miles an hour forward and 14.5 miles an hour up. And that's before gravity starts affecting it and all that other stuff. Okay, so just 3 quick examples. Okay, I'm watch this video. I'm going to put a quizzes up. I'm not going to try to put too much pre-calc stuff for you guys this week and next week because I know you guys got AP tests coming. So just enough to keep you getting a little bit of math. But once again, hope everybody's good. Good luck on your AP tests if you're taking them. And